In this video I'm going to take a look at question 7 from the 2017 higher level paper and offer a suggestion as to how we might answer the question. So starting with the question here, we can see that it's a slated roof. All these clues are in what we have to answer. Prefabricated truss roof, so it's not a cut roof, it's a prefabricated truss. It's at 45-degree pitch. The span is 4 meters on the internal from wall plate to wall plate. And the roof is on external walls which are of timber frame construction, and the external block or external leaf is a block built. And we're told that it's highly insulated walls, and the scale is 1:10, so we know what we're supposed to be drawing in. And I have to show details from 400 millimeters below the ceiling, and we have to show both external walls or include both external walls, and only show detail at one of the eaves, and include battens, membranes and 4 courses of slate. And we're told here to label the components naturally enough. And the part B is 3 roof members to be shown. So to start with, in this drawing, it's a A2 page and the pitch of the roof is 45 degrees, so I've come very close to the top of the page and drawn 45-degree lines down both sides. I'm allowing a thickness of 150 millimeters for the rafters. It may be difficult enough to see there. And then I draw a centre line, and from the centre line I'm measuring my 2 meters left and right to allow for 4 meters between the wall plates. And then I can start to draw the timber stud for the inside wall of the timber frame. Now I've taken it to mean that the internal span is actually from wall plate to wall plate. I don't think it would have really meant that it would have been to the actual surface of the inner wall, because you'll have your service cavity on that there, and to be honest with you, it's a struggle enough to fit this on an A2 page. And you can see there it's starting to build up here now where I have my ceiling as well too. I come down my height of 400 millimeters below that, so it's 40 millimeters below where I've drawn in an insulated slab or a service cavity as my ceiling there, and I'm drawn in just the lines to a 1 meter interval and a single line, using it to draw the Fink truss rafter. And then I'm going parallel at 90 degrees with my measurement of 150 millimeters, so it's 15 millimeters for each of these here. And quite simply, they're just taken to half of the span is divided just to get that center point of the Fink, and it's 90 degrees as you can see there. I just went 45 degrees back in, and there's a little bit of maneuver at the top as well too for where you actually place that there. But general shape of the Fink truss rafter is shown here, and it's all taken off centre lines. And you can see I'm starting to draw in the nail gang plates, not really measuring those as such, just whatever looks good. They would be a bit different manufacturers of different sizes and things like that there. Some of them will be shaped at the top. I'm just going to draw a fairly basic kind of triangular type shape, but that you would have in the nail gang plates anyway. And I haven't drawn the eaves heavy because I want to find out where I want to finish them off. It didn't tell me anything about a soffit size. I'm going to allow maybe a 300mm soffit. And we can put in the details we would have, like your double header on the timber frame stud that I've zoomed into here now. I'm drawing the block for the outside wall. All these things are mentioned in the question, and once you have those highlighted in the question, you know you're going to be getting marks for each of these that you put in. So you can see there I have my wall tie placed in, I've got the cavity closer, each of the parts of the stud, the insulation, because it's in the question that that was a highly insulated wall. We've got the membranes, and the OSB board is used on the timber stud as well too. It can be highlighted in, tilt and fillet, fascia, soffit. All those things can be placed in and drawn in felt, or you could even put in like an air tightness type membrane as well too there. We've got, from earlier drawings that I've done, my slating details. Very simple once you go through the slating detail from before to be able to put those in. Time consuming, but fairly quick to do. And I'm not going to explain them here as it's done in the previous video. And it asks for 4 courses of slate, so I'm working my way up here. I don't think you'll be penalised if you go one more, just that it has the laps being shown on them there. That's quite time consuming. It didn't ask for the detail. I don't think it's unnecessary to go through all the details of the eaves on the other side. It did ask in the question to include both the external walls, so I'm going to draw a little bit of detail here. And the exam, if I was pressed for time, I would probably only do the left hand side and maybe leave the outline of the other side, and without completing all the detail in it, because I drew this here under the pressure of the clock, and it took me, the way you see it finished here, took me the best part of 40 minutes, and you won't have that in an exam. So some shortcuts have to be taken to try and draw something like this here. As to why the scale is so big, I really don't know, because all the detail that you need is really up to the eaves. Half that page would have done. The insulation that I'm showing here, again, normally it's nice to put in that detail where you have the kind of spirally line showing the insulation, putting in the eaves ventilator. But a little bit of colour will get us away without having to do a whole load of detail in there, because again you're going to be beat for time in the exam to try and do that. You can see I've put in the air tightness tape and air tightness membrane as well too, shown in there. We can label all these at the end. Again, when it comes down to it, if you're really stuck for time, be aiming for something like 14 to 16 elements to make sure that you label them in. The question did specifically ask for naming sizes of elements, so I'd be very careful to make sure that I put in the sizes of elements, even though that part B of the question is pretty low on marks, and I'm showing the wee ventilation space here that's shown inside. So if you manage to get that there amount drawn, you'd be doing very, very well. I would be saying concentrate maybe on one half side of it, and do very well one side, and the other side maybe under the constraints of time as best you possibly can, and making sure to label each of these things. And it is even stated in the exam to label, so it's very, very important that when you draw something you go to the trouble of labeling it, otherwise marks will be lost there. So as you can see, I'm labeling each of these elements that I have in. Just work your way through each of these. I've mentioned quite a few of these here before, but around the eaves details there, you've definitely got 6 if not 7 elements there, like the closer, the wall ties, fascia, soffit, vent, etc. Battens, make sure you put in the size of the battens, your 50 by 30 or 50 by 40 battens, the felt, the breather membrane, eaves, ventilator, truss, gang plates, 600mm centres for the truss rafters. Sizes there that you want to have in for your trusses as well too, like your 600 centres, 150 by 40. Put in the insulation size of 400mm mineral wool, and there's a 200 to mention the U value maybe that may be achieved by that there. The timber frame itself, the breather membrane, double head plate, which is 200 by 50 studs, 200mm studs at 400 centres. They're the sizes, they're nailing the parts that you have to put in sizes for. All those, remember, it's something like about maybe 14 to 16 elements, and you're well on your way to full marks. Not the most challenging of drawings to complete, but definitely within the time frame that was given for this here, and the scale, the amount of stuff that you take in, that was where the challenge lay there. So definitely well worth practicing something like this.